Before therapy, Liam was, how I say, not understanding guy, and he doesn't look in the eye when I called him. He doesn't respond.
I'm a therapist who goes to therapy, and some people think that's strange. The thing is though, therapists are human beings just like you. If you've been thinking about
Thanks for having me here. Hi, so today I'll be going over my project.
So I'm going to talk about gene discovery, which is what I'm
pages and thinking, I'm going to find myself a CRISPR editor.
The only thing that has been given
Autism.
I don't think there's anything worse in the world than having something wrong with your kid. It's just...
Without a voice, without words.
It's just been so hard, and it's been such a roller coaster.
Without a voice, without words, he...
Let's bring parents Gina and Wade into the discussion now.
I see both of you moms over here crying. Talk.
Hey, this is Josh, Dream Body Clinic, and we're getting called and asked more and more about autism. So we've been treating a lot of kids for this. Been getting kids from all over the world. It doesn't seem to be just one country in particular. We've had kids from the US, Canada, UK, Bulgaria. We've had kids from Sweden. We've had kids from, and then here is a kid from Australia, all the way around the world. Just because there's not a lot of places that can do what we can do. Fortunately, here in Mexico, we are able to culture.
I just did that whole monologue and my mic wasn't on. I'm so amateur.
All right. Let's get this. So basically, what we're looking at today is stem cell research. I noticed yesterday when I was looking at the I did all that. I did a whole monologue and everything, you know. And I'm like, my mic's not on. I'm such an idiot. Damn. So anyway, when we were closing out yesterday, we came across some stories about stem cell research, and I noticed that there are quite a few that seem to pop up this week. And so as like I found out particularly this Chinese story, which is I found really shocking, I thought that it might be a good idea to do the deep dive, so to speak, into stem cell research, because frankly it's right around the corner. The Chinese are basically actively trying to find a cure. And you can see how the governments would want to fund anyone that wanted to do a cure, because we are projected as being billion-dollar problems, multi-billion-dollar problems. A multi-billion-dollar drag on the economy, multi-billion-dollar drag on the medical system. That's how we're perceived. So if we could be cured, then we could be, quote, productive instead of being a drain on society. And now I'm not saying that we are a drain on society by any means, but that is the perception and the stereotype that we have to fight against. That's what we're up against. That's what the even if it's not at the surface, that's what the ableist background, ableist kind of thinking is, and it's because it's a societal thing. So.
Hey, this is Josh, Dream Body Clinic, and we're getting called and asked more and more about autism. So we've been treating a lot of kids for this. We've been getting kids from all over the world. It doesn't.
Okay, so you get this already? I was not aware that stem cells treatments were being used on autistic kids. Now, I think this guy's in Mexico. There's another guy that was out of Serbia. Another clinic out of I can't remember. Let's see. This guy's Mexico. So there's Serbia. There's another country. But all these random countries all over the world. Not any European countries. Go figure.
It seemed to be just one country in particular. We've had kids from the US, Canada, UK, Bulgaria. We've had kids from Sweden. We've had kids from, and then here is a kid from Australia, all the way around the world. Just because there's not a lot of places that can do what we can do. Fortunately, here in Mexico, we are able to culture mesenchymal stem cells. That means we can replicate them in the lab. We take them from umbilical cord tissue called Wharton jelly.
Okay, so notice that we're talking about all this stuff, but this is what's really weird and creepy about all these things. They never quite say why they're doing this. They never quite say a cure. They always dance around it, or they just talk about all the things that they can do, and they just kind of leave it to your imagination. This is not proven to do anything. This is, at this point in time, this stem cell treatment is snake oil. Because it's not like in Vietnam and Russia and these other 6 countries, there were studies that found that this was effective treatment for blah, 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 and it has not been accepted by the United States yet, or something like that. No, that's not the case. this has not been found to be valid, has not been found anywhere to work anywhere. Now, it isn't pretty much in the experimental state. I do admit this. And I think with AI and quantum computing, that within 4 or 5 years or whatever, we could have the complete genome as far as autism and so forth, and the switches that turn the genes on and off. And this is already being framed as, oh, well, if we cause, yes, we're going to cure autism by accident, but by doing that, there's so many other diseases that we can cure. And that's how you'll see it's starting to be framed that way too.
And from placenta. These are great tissues because they have a high concentration of capillaries. Mesenchymal stem cells live on the capillaries. Think of my arm as like a capillary tube, and they're like a little octopus wrapped around it right there. And they come off, they target inflammation, they start healing. The problem is, as we get older, we have fewer and fewer. So for kids, you'd think they'd be doing okay, but when you have autism, things aren't quite working right. And that seems to be the problem. There happens to be a big connection between gut health and brain health. We're seeing a lot.
And I've talked about that a lot, about the brain bone is connected to the stomach bone, and how important probiotics are, and how that we know the brain and the stomach are definitely connected.
A lot of these kids with issues there, so we do an IV, 100 million mesenchymal stem cells. Gets right to it, starts healing, guiding that regeneration. We also do an intrathecal injection, which gets to the brain. That starts guiding neurogenesis.
Did he? Oh boy. I think he just said fecal. I think that's what he was saying. It says, I think he said fecal.
Also do an intrathecal injection, which
no, he said thecal, T-H-E, thecal, okay.
To the brain. That starts guiding neurogenesis, removing waste.
And the reason I say is because there is poo. There has been getting poo from other kids and putting it inside autistic kids to try to cure autistic kids. There has been some weird stuff.
All of that. So again, we are lucky to be able to do this here in Mexico. Other countries aren't really allowing it, and not for good reasons. It seems to be mostly greed. It seems like, things like Big Pharma and whatnot really don't want it. They've created these impossible to overcome scenarios where they just won't let them get approved. For example, in the United States, where I'm from, you would have to first start a lab, get it all up to above GMP standards, which, you're going to spend millions of dollars on that lab, getting everything going, employees, and then you would have to...
Basically, he's saying it's too expensive to try to do it in the United States, or too hard to try to do it in the United States. But if you can go to Mexico, where it's a hell of a lot cheaper, there's less regulations, and so you can do things that you couldn't do in the United States. That's what it boils down to.
File for a new medicine application, because even though mesenchymal stem cells are natural and existing, because of the manufacturing process, they now consider it a medicine. Well, that's $2.5 million. I know this because I know a guy who helps Pfizer and other big name companies buy labs around the world. He worked with a lab up in Idaho doing this, and yeah, $2.5 million just for the application, which they can deny for any little reason. Maybe you forgot a period at the end of a sentence, something stupid and simple. Then you got to file again, you got to pay again. Then, if you do get approved, you have to get through all 4 phase trials of the FDA. You can spend hundreds of millions of dollars, and unfortunately, you can't patent mesenchymal stem cells because they already exist in your body. So we get asked this a lot, what's the advantage? Why should we do it that versus using their own?
Okay, just understand that we're talking about stem. He's literally having a conversation about stem cells treatment for autism. Why? This is so weird. It's like I said, the context is so strange.
That's the main advantage, is that we can expand the cells. The first round, like what they do, there's 1 or 2 clinics or labs in the United States that can do this. They'll use the whole umbilical cord, and that's awesome, but that first round cells are not the best because it's been a traumatic event removing them from their host tissue. So they don't work as well. They work via what's called the paracrine effect. This is the signals that they send out that communicate with the other cells, the trophic factors, the cytokines, the chemokines, the exosomes, all these things are released. Well, they've been traumatized. They don't release as many. So we put them in this perfect bath and we start replicating them. And they grow up, the replicants, just completely perfect. It's heaven for them, healthy cells. And you get a doubling each time you do that. So it's 2, 4, 8, 64. It is exponential, which is what you want. But we get so many cells from these, we really don't have to expand that many times. Once you expand too many times, you run into other issues. Once you get to the 12th round of expansion, cells start changing shape. They should be a nice circle under the microscope. You need to use an inverted microscope to do this. And
now there's another guy later on that touches on this. This guy, I really like the fact that he's getting into this detail here. Because it does apply to what we see later on in other videos.
They should be nice and round. After the 12th round, they start to get kind of oblong. We don't want oblong cells. They will replicate forever. They're considered an immortal cell line in that regard, but they get weaker each round, and after the 12th round, they start to misshape.
So this is for very, very rich people. Just keep this in mind.
So the Goldilocks zone seems to be between the 3rd and 6th round of replication. So we try to keep that in the 3rd to 4th round whenever possible. Only when we're doing a lot of cells for someone do we really go to the 6th round. So get a lot of cells, we get those into patients, and it helps them to heal and recover the best. It's all sterile. All the women who donate are between the ages of 18 and 25. Go through a whole screening process.
All the women that donate are between 18 and 25. Now I can see like freaking young woman trafficking for the purposes of stem cells. I mean, oh my, oh. No, I moving right along.
And the best part is stem cells don't have what's called HLA, human leukocyte antigen. That's what would tell your body to reject it. So no chance of rejection, nothing to be afraid of from these. They're nothing but healthy. We do not take from vaccinated donors that have had any of the COVID vaccines or mRNA vaccines.
What? We do not take from vaccinated donors.
That have had any of the COVID vaccines or mRNA vaccines. So
wow. So are these women getting paid then for these cells? Are they purposely not getting vaccinations so that they can get paid by these people for these cells? Are these young women putting their lives in jeopardy to qualify for this program? And where are these women? He's in Mexico, so are these young Mexican young women that are being taken advantage of for this? Are they being taken advantage of? That just sounds so weird and creepy.
you're going to get the healthiest cells possible from healthy donors who are from, live healthy births. We're not hurting any babies in this process. They're completely ethical. And it's, the best thing you can do for your child.
This is like you would see at the beginning of a horror movie before everybody turns into zombies or turns into some kind of creatures. And then the zombie movie starts. This is what this reminds me of, like the little training video they show at the beginning with the professor. Where he's trying to sell it to people in Dubai or something. And by the way, there was a lady from Dubai. She was the one that was in Serbia working for a company that, I can't remember what they were called. But I think they were supposed to be out of Israel or something.
Something like a mesenchymal stem cell therapy, because there's no cure for autism, but we're finding more and more things to move them down the ASD chart, hopefully more towards something like Asperger's as opposed to full-out autism.
Okay, you get this for something like Asperger's as opposed to full-out autism. He doesn't even know what autism is. He doesn't know that you can't be a little autistic. He thinks this is disease. He's talking in terms of it being a disease.
Stem cell therapy, because there's no cure for autism, but we're finding more and more things to move them down the ASD chart, hopefully more towards something like Asperger's as opposed to full out autism.
As opposed to full out autism. Oh my word.
And get them functioning. We're seeing kids that could not follow instructions, following instructions, kids that couldn't even make eye contact, making eye contact after the intrathecal treatments, kids that only ate 1 or 2 meals and nothing else, or 1 or 2 types of foods and nothing else, eating a whole host of food just like their parents. It makes a huge difference for these parents. And that's our goal.
It makes a huge difference for these parents. That's the important thing here. It's for the parents.
It's to help the kids, help the parents, help them have more normal lives. It's not a cure, but we're seeing some great progress, and we're always innovating. We're adding even more brain types.
It's not a cure, but we want it to be. It's not a cure, but it's as close as we can get.
Cure, but we're seeing some great progress, and we're always innovating.
See that? It's not a cure, but we're seeing some great progress. So he is looking towards a cure. At least this guy is. At least that's what it sounds like.
We're adding even more brain type medications. We now have cerebroliacin, which you can add to the treatment. This is a group of peptides, 14 different peptides that cross the blood-brain barrier, can get in there and help. It's been approved in Russia for a very long time for things like for stroke recovery, traumatic brain injury, as well as Alzheimer's and dementia. And now we can add it for kids. They're actually done quite a few studies in regards to even things like Down syndrome, and they've seen some progress there. So for autism, not a lot of studies, but it seems to be working, and it's perfectly safe on kids.
You think the Russians aren't the government isn't into eugenics? I guarantee you they are.
Kids are adults, so it's good to go. So you can look at that on our website under cerebroliacin. You can check out our autism protocol. Typically, and it does depend on the age and size of the kid, we do 25 million intrathecally in the operating room, plus 100 million IV in the operating room to make that as simple as possible. Then 2 sessions of 25 million via nebulized. This is where they put on the mask and breathe those cells in, cross the blood-brain barrier, a lot of them, and or go to the mucous membrane to cross the blood-brain barrier and get up there. Okay. So we try to hit the brain.
Okay. That was kind of creepy. Okay, so we got this kid from the UK, and in some parts I'm going to skip ahead because he kind of...
Hello, welcome everybody.
I think he takes about 3 or 4 minutes before he even begins. Yeah, I think he might start here.
Reading neurodivergent research. Neurodiversity, of course, is the diversity of humankind, including the cognitive variation we all possess. Can CRISPR, which we will learn is editing DNA, can it truly go side by side? We're going to be looking at treatments for neurodivergence. This is controversial because the neurodiversity movement in its kind of pure essence is we are fine just the way we are. We do not need treating. Treatment sometimes sounds like we're trying to get rid of something, but it could be used in another form, that making someone's life easier, more comfortable.
And I'm with that. And particularly when we have high support needs autistics that are uncomfortable all the time, say they always, like, I always itch actually. It's not something that I can't deal with, I've dealt with all my life. But I always itch. I always itch. I itch right now. I just have learned to kind of tune it out in a sense. But you know, things like that, or kids that experience, that have particularly high sensory issues and so forth. Yes, of course we want to treat that. When it becomes completely debilitating, of course we want to treat that. But the thing is, this is the questions where we're going to have to answer is where is the point, where's the starting point, where's the stopping point? if we can make someone just Asperger's instead of full-fledged autism, why not cure? The cure is for autism is going to be through stem cell research or whatever else. That's going to be the only pathway that it gets, basically, is through DNA somehow. And it is going to happen. I've got a story from out of China here that we'll get to after this bill is done.
Could we not, for instance, get rid of autism completely, but just get rid of the key limiting factors which can make some people's life very challenging? Could it be that is optional, that people could have, they could opt in or opt out? These are questions which are being raised right now. Ethical issues, if we start cutting away DNA, where does this end? Sounds a lot like eugenics. Hitler would have loved CRISPR. Controversial take, but it does sound scary, doesn't it? The fact that we could literally change someone's personality. We could change... Yeah, Lisa, that's your concern. And it is a concern. We have to know it to research it. And lastly, how could it benefit neurodivergence? If we nurture it, if we have the right support in place, could this be an amazing thing which cannot hinder genetic diversity, but allow it to really flourish? Let's find out. Some new terms, because I appreciate this is a subject which is not familiar to many people. CRISPR is, in its short, gene editing technology. It isn't future, isn't sci-fi, it's happening right today.
And it's fairly inexpensive and, so to speak, easy to do, so to speak. Which is the brilliance and why it's loved so much. So basically, any lab in the world can utilize this CRISPR technology.
You can edit someone's DNA. You can take bits away, you can add bits, you can alter bits. There is so much you can do with it. A genome. This is all the genetic material in an organism. Think a nice bit packaged up. There you go, this is everything of who I am. Then pluripotent stem cells. These are stem cells that can become different cell types. When we are born, when we are just developing in the womb, we have unlimited possibilities. That little stem cell, could become an ear. That stem cell, maybe a lung. It could be anything. But if we were to use that same kind of cells, we can program it to be whatever we want it to be. Obviously, controversial. It used to be that people thought we had to harvest it from babies, but now we realize we can gain it from other areas. And then we have nuclease. That's an enzyme used to cut DNA. Though I was showing my trusty scissors today, which I've been using for wrapping presents, it's not like we're actually cutting DNA. We're using an enzyme which kind of attaches on and cuts it that way, but it's not cutting in the traditional sense. Now, a quick question before, because I'm taking a lot for granted already.
Basically it cut and pastes the DNA. Is what it does. That's the easiest way to put it. It's just cut and paste.
How familiar are you with terms like autism? Now, what is CRISPR? I put some packet of crisp there because that is the first thing that always comes to my mind. Like, sounds tasty. But what is it exactly? Now, let me know your understanding. I've given like a really basic understanding, but what is it really? It stands for, and this is where I'm going to butcher it, so sorry. Maybe I'm not. Hopefully, so actually, I would have struggled with pronouncing it anyway. But it is an acronym. I think it's an acronym, right? Yeah. We've got a form of gene editing, and yes, a form. There are multiple types. CRISPR does tend to be the easiest and the cheapest, and relatively quite new. It is an exciting place to begin. Brand new for me, don't worry. Okay, to cut out genes, a tool to edit genes. Think of it a bit like this. You know when you're writing a document on Microsoft Word and you spell a word wrong? Back in the day,
you're cutting and pasting. That's all you're doing. It's cut and paste. That's all he needs to say, but it gets into this long-winded thing. It's cut and paste. You take this one piece out and you put the other piece in.
Exactly what it is. Is a tool, could it be a tool to understand neurodiversity? So here, you've got your DNA. This is your like genetic information. This is everything of who you are.
Skip a little bit of that.
All you need to do is let me know, what is CRISPR? Now, fingers crossed, you know this by now. Is it a cooking technique? Sounds like it could be. A tool for CRISPR and neurodiversity. What is the connection? What joins these two seemingly unconnected things? One is a type of gene editing, another is the way we process the world. Okay, we've got by diagnosing them, yep. By computer programming, yeah. It's not related at all. Oh yes, developing treatments through understanding genetics. Absolutely. Yep. How it connects is the more we understand about genetics, the more we're able to support people. We aren't talking about a gigantic cleanse of all forms of diversity to create one super race. Easy, Hitler. What we are talking about, how can we make people's lives easier, more supportive? How can we allow them to be the best version that...
And that is always going to be the justification. And it's hard to argue against. And nobody's going to argue against making lives easier and being more supportive. But a lot of times it's the methodologies that we have to be concerned about. And with the implication of if we say yes to that, then how much closer are we to actual genocide, where we just completely edit the DNA so nobody's ever born autistic again.
They can be, regardless of what society's expectations are. So you can see how, depending on your viewpoint, this can go extreme or really optimistic. Now, I think most of us can agree, when it comes to mental health illnesses or diseases, this sounds like a no-brainer. But it's when we come to things like neurodiversity, where I'd say the ethical decisions really kick in. So CRISPR in ND modeling, this is it, super, super simple. First of all, we need to find the autism gene, for example. We should all know by now that...
And with the advent of AI and quantum computing, I think in the next 5 years we could very easily have the time for... Because you've got to understand, now, getting access to this computer, these quantum computers are going to be popping up. That's going to be a pain in the butt probably for another decade. That being said, once you do get access to it, what may take 40 years of research, you might be able to get done in 4 minutes. And I mean, you're likely to get done what you probably couldn't get done in 40 years. So the power of what we have available now, and we do have that power available right now. Obviously, like Google has their quantum computer, and they're doing whatever they're doing with it. And I think there's at least one or two others floating around somewhere. But yeah, it's definitely something that we got to keep in mind. This technology, these conversations, these things are happening right now. And we really need to be having these conversations right now so that the autistic community is leading these conversations rather than reacting to the decisions that have been made by neurotypical people, which we have a high propensity to do.
It isn't an autism gene. Autism, it comes from a number of genes and also environmental. We first thought maybe there is like this particular really rare gene, when actually what it looks to be is autism is many common genes. Autism genetics is really common, but it's like the sheer amount of them, and that's why it's different for everyone. Right off the bat, while we possibly could find a particular area for an individual, that doesn't mean it would be in the same place or same location for another person. That is our first problem. Create models. Edit genes using CRISPR. We can create models and we can see, okay, now we understand what the model looks like. We can choose what to keep, what to take, what to move. Naturally, you wouldn't want to be the guinea pig, would you, who has to do this first. But if it's a tried and tested method, which works the same in everyone, this could be great. I don't think we're dealing with that here when it comes to neurological differences, though. We want to...
And I think that like quantum computers or whatever would be able to scan your DNA and be able to fix everything tailor-made to you.
Study effects. We want to observe brain changes. Let's say we get around and we're like, how does that affect someone? And does it affect different people differently? And is it safe to do? Then we want to observe changes. So is the brain now operating differently? And explore treatment, develop treatments based on findings. To be honest, a lot of this we could probably do in mice and rats. And we wouldn't even dare do it on human trials for a crazy amount of time until it is safe. But it's still something. And the next question is, do animal models really represent humans? Well, there are a lot of similarities, and it's not a bad starting point.
Now, it is believed by most scientists, as I understand, that, or at least by some scientists, that animals are autistic just like we are. And so, could animals be used to discover things about autism? Yeah, possibly.
But it doesn't tell us everything. But
we're talking about a neurological issue and how the brains are wired. So it may not even matter as much as the brain type, as much as how it's wired. So it could affect vastly different brains, but affect it in the same way because it's how it's wired, so to speak. Rather, how it functions rather than which the department is actually there.
For instance, we roughly know how a rat thinks. We've observed them for ages. If we change DNA and it starts thinking differently, then we know it had worked, whether correctly or incorrect. Here is an example of CRISPR in Alzheimer's. Obviously, Alzheimer's and autism is very different, but there is some overlap. This is a very complicated image, so I don't expect any of you to take it in. But essentially, there's lots of different kinds of...
overlap is it's a neurological thing. Alzheimer's is definitely neurological. And autism is neurological also. But it's not a disease, it's not something that we get. With Alzheimer's, I don't know what the origins of that is. I don't know why people tend to get it.
Of genes, and it will be able to pinpoint the exact one, cut it, rewire it, and essentially in the brain, when you've got Alzheimer's, it's part of the brain kind of deteriorate, and then it spreads almost. If you can cut that bit out, then Alzheimer's begun, potentially. And you think, if we're already doing this in Alzheimer's, which, let's face it, is unanimously terrible, could a similar thing be used in autism? Now, this brings us on to challenges and ethics. I just want to get a feel of the room. How are you currently feeling about what we're talking about? Are you very uncomfortable with the subject? Are you neutral, is what it is? Are you very comfortable? What are the main complexities? Regardless of whether or not we like this, is this even possible? So is it the genetic complexity? The fact that all our genes are so different? When we are talking about neurodiversity, while we talk about individual conditions, there's no such thing, as far as we're aware, of a dyslexia gene, an ADHD.
There's a huge combination of genes that are kind of interacting together that may all have something to do with autism. While not any particular one may have anything to do with autism, even though it's in that same group that is affected by autism.
D gene, we are just loads of different characteristics, and diagnostic labels are precursor or remnants of psychology and don't really represent neuroscience. Then we've got ethical concerns. This is morally, is it correct?
Now, what he's talking about here doesn't represent neuroscience, so he's probably of the same opinion as I am. I think if there was a such thing as an autism doctor, that the basis of that doctor should be a neurologist. And then we can worry about psychology and other things like that. But the main basis of autism, as we know and understand it, is a neurological issue. I'm not even necessarily going to say disorder, but I will say a neurological thing, a neurological difference, more of a neurological difference than by far than a psychological difference. But I think the psychological differences are like depression, what have you. I think that's secondary to the autism itself anyway. So the main issue is actually the autism.
Psychology and don't really represent neuroscience. Then we've got ethical concerns. this is morally, is it correct? And thinking about it on a societal level. We've got unintended consequences. Are we creating the next Frankenstein? Hopefully not. But you could see, are we interfering with human, well, are we playing God, essentially?
And this, are we playing God? That is a moral question. That's a sociological question, not a scientific question. Has nothing to do with autism. Absolutely nothing to do with autism. But particularly in the United States, where you have like Christian extremists all over the place, that is going to be a big factor, particularly when you're looking at different legislation or whatever that may or may not be applicable to autism in this country.
Individual variations, knowing that, again, everyone is so different, and society and regulatory challenges. Even if this was possible, you can know for sure that, say, Texas is going to be like, nope, not doing that. Sweden might be all for it. Depending on where you are in the world, I think there'll be very different stats.
Sweden was the other country that where they were doing the stem cell thing. I believe Sweden was one of them anyway. I know one's called the Swedish Clinic, so maybe it was called the Swedish Clinic, but it's in Serbia.
Answers, and it could create an underground market. Genetic complexity wins. Yeah, it is not a simple task, but another little kind of ray of hope, if this is something you are interested in, AI is ridiculously good at solving complex problems. So long as it isn't impossible, AI stands a very good chance of being able to work it. We already have the genome, like kind of the map of humans. Now it's just about finding it out. Naturally, you've always got to look at the human studies. Are we taking people from all different backgrounds? But we do have the building blocks already. All right, for next one, we've got CRISPR and neurodiversity, ethical challenges. Lisa says,
and this is one of the big things is the ethical questions that we have. And like I said, we need to be the ones asking these questions and coming up with the answers so that they aren't answered for us. Because people are just going to assume that we don't want to be autistic and assume that we want to be cured. People want to be cured of cancer, right? Why wouldn't they? Now, if they're an autistic person and they don't want to be cured, it's obviously the autism. And obviously they don't know better. They don't understand because they're autistic. So it doesn't matter what they think. And this is the way that of course I'm not saying that, but because I am an autistic person. But this is the way this type of thinking is going to be framed. And this is what we have to put a stop to. This is what we have to change. This is where we have to take care of. This is where we have to take control of the narrative.
I think there are about 35 genes that code for autism. I have definitely seen that, Lisa. Truthfully, I don't think we know yet. If we knew all the genes for autism, I think we'd be much further along in our development. I think we have some areas which are real hot spots, which have definitely shown for some individuals. But truthfully, I think our definition of autism is too broad to really nail it down to a particular set of genes. Oh, no, there are way more genes than 35. I think 35 would just be the ones we've got our eye on. Okay, let's have a look. We've got genetics in
I saw on another one of these saying that they were basically looking at like 435 genes that may be involved with autism, may be involved.
Neurodiverse knowledge. So the more we know about genetics,
and there is a much narrower group like this, probably this 35 that they're talking about, that they're extremely interested in, at least enough to do actual testing with.
The more we can support people, sounds good to me. Ethics are key in neurodiversity research. Some of you didn't agree with that. I do think we always have to question, not if, is this like a, I want to say Jurassic Park quote? I don't know. No, we wondered if we could, not if we should. And it is that question, just because we can do something doesn't mean we should.
And And if we can, as human beings, we will. If we can change the DNA, if it's possible for DNA to be changed to cure an autistic person, and actually there's no such thing as a cure of autism in that respect, but if you were to make an autistic person into a neurotypical person and we call that a cure, if that's possible, it's going to be done. I don't care if it's ethical or not, it's going to happen. And right now, there's, when we get done with this fella, I'll be coming up with the story from China that I found extremely interesting.
Genetic treatments for neurodiversity is debated. Some of us see it as a disability. We want to get rid of disabilities, ideally, so no one wants to be disabled. But do we want to get rid of cognitive difference and variations and people? No. So you can see, depending on your personal viewpoint, this might be very controversial to not at all. Research influences ND cognitive diversity. Actually, I just want to make one little clarification. When I said we don't want disability, when people have disability, of course we should be supportive and encourage them, and everyone has a place. But obviously, if we can avoid suffering from an individual or take it away, of course, I think most of us would want to.
And that's where the justification for curing autism is going to come in. And let's frame it this way. Let's say that your child, the doctor says your child's going to have heart disease no matter what, and is going to get cancer by the time they're 20. Or they can give your child a shot, and it's going to be some donor's DNA that aren't related to you, because you do happen to have some of that DNA that is the problem DNA. So, but basically, they can give your kid a shot, and they will never get cancer and never have a heart issue. Would it not be ethically wrong not to give them that shot to make sure that they never get heart disease or make sure they never get cancer? I mean, to withhold that from that child, would that not be ethically wrong? Would that not be morally wrong? So if we frame it in that way, it's going to be framed in the same way for if we can't cure autism, or if we can cure autism, is it not morally wrong to cure it? And if we catch it early enough, then that person was never an autistic person, so we're not committing genocide, are we? So yeah, and even though they could make it where no autistic people were ever born, but you can justify anything any way you want. And it already is being justified. So we are in a time right now where we are having serious conversation about stem cell research, and serious there are people selling treatments. I think it's snake oil myself, because it's not proven in any peer-reviewed papers. And if it was that legit, not to say that it can't be fixed, or that genetic research isn't there, very close to being there, but I don't think it's there yet. Although what they're saying technically about how you cut and splice the DNA and the CRISPR and all that, that is legit. But I don't think we understand the genome and so forth quite enough to have exact or extreme success with it.
That's just want to clarify.
Yet. But with AI and quantum computing, we could have that in minutes. Just saying.
So you can already see how this is a very grey area. Fair access to ND treatments needed. So we've got a few little things to think about here. Let's move back to Alzheimer's now. And what do Alzheimer's and autism have in common? Now, I have autism, and do I have Alzheimer's? I hope not, to be honest.
I have autism.
No.
like within the first 3 seconds of seeing this kid, I'm like, yeah, he's autistic.
Are they necessarily connected in that sense? Probably, maybe not. But are there connections on a genetic front? After Louise, many geniuses are autistic. I try.
Well, actually, to tell you the truth, he struck me as autistic a lot because of the way he articulates himself.
No, but then there's also many not, like autistic people who are wide varying. So we got both are genetic. Yes, Alzheimer's and autism are both genetic. Diagnosed at similar life stages, not at all. Autism is diagnosed very early on, where Alzheimer's is typically later on in life. Both affect brain structure.
Autism can be diagnosed later in life.
Sure, yep, they absolutely do.
But
they
not
both
typically.
alter how the brain processes and not caused by environment. No, they can be. And that's the thing, autism does have a genetic component to an environmental component to it. So as you can see, if we were to do it against studies we've already done.
When they say environmental factors, that means we don't know. We have no idea. It's genetic and something else. It doesn't necessarily mean that there is a specific chemicals that mother was exposed to in the environment, so to speak. That's not what they're talking about. They're just saying we don't know. 10% of it is we don't know. We have no idea. Are we going to get some of these answers and so forth? Are we maybe just a few years? Yeah, I think so. I think as I report this, I think even in the next year or stuff, I'll be reporting things that I can't believe. And I've got a damn good imagination because that's oddly my little autism gift thingy, I guess. Abstract thought. Whatever that means.
But there are also areas that just do not line up. What are your biggest hopes for CRISPR gene editing in neurodiversity therapy? And I think therapy is a nicer word, right? Because we're not talking about removing, we're just saying supporting people to live their best lives. On here, just move up and down to which one you think is the biggest hope to the least hope. Okay, number one, a deeper understanding of neurodiversity. Nice blurry picture of Steve Silverman and a quote from his phenomenal book, Neurotribes. Neurodiversity may be every bit as crucial for the human race as biodiversity is for life in general. What a quote. What this is saying is thinking differently is as crucial to the human race as biodiversity is. So biodiversity is all our nature, our animals, our...
And that's because, like, your Galileos, your Elon Musk, your Nikola Teslas, your Edisons, your Bill Gates, your people that have a profound effect on technology and the world around them often tend to be autistic. The guy who invented Pokemon, or whatever it's called, autistic. So, autistic people can have an extremely profound effect on the world, and if they weren't autistic, they obviously wouldn't have that same type of effect. It is a pretty cool thing sometimes.
Everything around it.
But those people's lives probably aren't easy at all.
And we need all of this to live unanimously. We are destroying our biodiversity, and as a species, we are suffering as a result. If we destroy human diversity, we will also suffer just like we are with the destruction of our biodiversity. Yeah, I personally love that. Who can say what form of wiring will prove best at any given moment? And this is really true. The way that we have created our world, it's that a certain type of wiring is the preferred way, and hence that creates disability for those who do not have that wiring. But if we allowed people a bit more flexibility, you'll notice that different types of neurology have different benefits and perks and strengths depending on different scenarios. So with that in mind, if we were to edit people's DNA, we potentially could lose this diversity of what makes us special. Are we going to be repeating the same mistake that we're doing with our biodiversity? Definitely food for thought. Moving a little bit along,
I think definitely, yes. I think there will be a move in that direction. I think there will be a move to cure autism because it will be considered ethically wrong to give birth to a child that you know is going to be, quote, messed up. Because that's how it's framed. And I do not think being autism. I don't think being autistic is messed up. I think it's a difference.
You heard of amyotrophic lateral sclerosis. Let's just say LLS.
Myotrophic. What was that he was trying to...
And so, no, L is a
amyotrophic lateral sclerosis.
Fatal disease that causes motor function impairment. In contrast, conditions like autism and ADHD are related to lifelong differences in the brain. These are different conditions, by the way, very different. One is how your DNA is wired naturally, and another one is when your connections in your brain are unhealthy. So say you've got your muscle, here you've got your neuron, you've got your synapses, you've got your dendrites, you've got all your good stuff here. Now, in ASL, this harms the motor neurons, making the muscles weaken and can become paralyzed. So essentially, your cables in your brain, which kind of get information through A to B, are now dead. So this is something which potentially CRISPR could be really useful on. We could edit out the dead neurons or the dead genes and make sure that you are healthy.
And refurbish the brain, essentially.
You can see there is maybe some overlap, but there's a lot of things that are quite different as well. In the UK, we tend to call ALS motor neuron disease. Oh, thanks, April. Ugh, I feel silly. Yeah, you are totally right. I should have used that. Appreciate that. While we know there is really interesting research happening, it doesn't necessarily apply to neurodivergence. On this screen, you've been given a load of money, and I want you to tell me, where would you invest the money? So we've gotten for autism, ADHD, dyslexia, and dyspraxia. These are things which are theoretically possible, but still have a lot of develop to go. We have autism, CRISPR on social genes for therapies. The fact that we find things socially awkward and can be cripplingly destroyed with anxiety. Should we look at ways to support and to minimize that? ADHD, what about the attention gene? If we could get rid of the inattentiveness and allow people to concentrate more, would that be a good use of time, research, and funding? Dyslexia, CRISPR on reading genes for learning. So when people struggle with learning and the way they interpret written information, we could completely remove that and make sure that people can read nice and simple. Dyspraxic coordination gene, so allow you to be more coordinated. Do you know what? I'm struggling with this myself because let's face it.
I've got dyspraxia myself, and this is a valid question. Would it not be right to heal that if we could? Through gene replacement therapy? That would be changing our genes and how our bodies work. It would be changing who and what we are. I wouldn't mind getting along a lot better. I am off balance all the time, and I don't like that. So I wouldn't mind that being cured. So if I had a child at this point in time, and I could, it was up to me to make that decision, I would probably make that decision that my kid would not have dyspraxia. Because it sucks. But now here I am, a person who's very much against this gene therapy, so to speak, as far as curing autism. Here I am admitting that I very well would do it myself in certain circumstances. And that's why these conversations need to be going on, and why we need to have them right now. I don't want neurotypical people guessing or thinking that they've got it right and thinking that they're representing my thoughts when they're not.
A lot of the negative characteristics of conditions, they can suck. They can be really challenging and they can make life really difficult. But if we get rid of them, what's left? And I think neurodiversity is about the fluctuation of abilities. It's about the skills that are really high and the skills that are not so high. And I wonder that if we crop out the low skills, are we creating superhuman soup, or are we ridding diversity? Maybe highs and lows are both necessary. You can't have your highs without the lows. Again, more food before. No,
I was just laughing when you can't say superhumans. when you can't say superhumans, oh man. Must not be a superhuman yourself.
particular answers as of yet.
I stuttered too, buddy, okay?
Now, CRISPR requires specific ways for tricky conditions. The ones we're talking about, ADHD and autism, are tricky. And there's a few reasons they're tricky. Let's look at the spinny wheel of trickiness. Delivery. How it is delivered is going to be different for everyone. And let's face it, it is invasive.
Yeah, and what we were looking in that other one, the delivery methods he mentioned was inhalation therapy. Another was IV, another was orally. And I don't know if they did it from rectally or not. But basically, he was saying that there are all kinds of different delivery systems depending upon what they're trying to treat.
In some forms. And then we've also got precision. How accurate is it? Let's say you want to cut off this bit of DNA, but you accidentally cut off this bit of DNA. It may not look like a big difference, but it could have unforeseen circumstances. We've also got safety. Is it safe? Is it reversible? If we don't like it, can we turn back the clock? There are a lot of other things to consider. Let's summarize now. Ethics in neurodiversity gene editing. Consent. Informed for vulnerable individuals. Those who would probably most benefit from this type of technology are probably those who are the most vulnerable in society. Who is making this choice for them? Do you have to be over 18? Do you have to a certain level of IQ? Are your parents able to make that choice for you? Stigma. If we continue down this route, are we going to be undoing all the advocacy we've been doing for years and years? We have finally made people realize that being different is an advantage in a lot of places in society. There's still work to be done, but we have come a tremendous way. If now we are saying, actually, if you choose not to be fixed, you're the problem, you could see how this could send us back like 50 or 60 odd years. Then we've got equity, ensure fair access, and
it could set us back thousands of years.
Benefits. Let's face it, this is going to be expensive, and
so to speak.
It means that people from higher income backgrounds are going to have higher access to genetic editing, and they have an even greater unfair boost compared to the rest of us.
And we're going to see that today. What he's talking about. I don't know about unfair access or whatever. That's more subjective. But I've talked about rich people only being able to, like the lady from Dubai being able to go to Serbia, or people being able to go to Mexico to have their kids treated. Even if it did work. Yeah, that is a disparity, and I don't want to discourage anyone, you know, if there was a valid medical treatment or something, no matter what that medical treatment was, I would absolutely encourage people to get that wherever it was, is what my point is. So I wouldn't discourage anyone from getting some kind of valid treatment.
Complexity. We've got to appreciate this is not an easy thing to do. This is real high-end stuff. And long-term, we do not have the studies yet because this is far too new to see how this will...
No, what we need to keep in mind is that the first person diagnosed with autism just passed last year. Just passed. Pinkerton? What's his name? Pinkerton? Or whatever?
Will affect us later on. I'm going to talk about bananas now because bananas are lovely. Bananas are genetically very vulnerable because we used to have lots of types of bananas, and then we found this really delicious banana. Oh my god, what a great banana it was. So we started to clone the banana, and we use its genes and would make copies of copies. Pro, no seeds, really easy to eat, very easy to create the optimal conditions for growing. But now, basically, every single banana is vulnerable. All it takes is for one really bad disease, and if it catches on one, it's going to wipe completely out, and then we've lost that banana forever. You could see how that could apply to other areas. Same with like grapes that have no seeds in. They're great for us. I flippin' hate grapes with seeds in. but it's terrible for diversity because we're just cloning the same mistakes, and it makes things really vulnerable. Oh, Peg says, what are the medical concerns of newborns from mothers that were gene edited before the child's birth? Now, that's a good question. I don't know the answer to that, and I don't know how possible it is to edit genes within the womb. I would have to do more research on it.
I'm not familiar on that yet, but we will have that technology very soon. Guarantee you.
That's even been done before, but it's definitely, there's possibility that it's something that could happen.
I mean, I think by soon I mean within the next decade or so. I think maybe two. It might be 20 years would be the max. I can see it waiting. But I'm thinking more like a couple of years, 2 or 3.
All I was saying is I'm not ruling it off the table. Our key takeaways today is CRISPR edits genes effectively. It does actually work, okay? There's been no negative repercussions that I'm aware of or that I can find. It does actually work. Studies, and it does treat brain conditions. While it hasn't been done on neurodivergence yet, it has been done on conditions which are unanimously bad, and getting rid of a particular gene could benefit someone's life. It has also been studied substantially on animals. Overcome stem cell limits. We know that stem cells are used in order to grow new organs and things, but we are limited at being able to get these stem cells. This might be another route around it. Precision precisely changes genes. If you want to change your genes at the moment, this is really precise, but does it need to be even more precise? And edits brain condition genes, like in autism and schizophrenia. Possible, but debatable whether or not this is something we should even entertain. Regardless of whether or not we're going to entertain it, if it's possible, people always do it.
Eugenics.
Can it work with schizophrenia?
Eugenics. This is straight up eugenics right here. Edits brain genes like in autism and schizophrenia. If it edits brain condition, and we're going to get into this, where we're talking about specifically editing the brain condition. That's what this is all about, and that's why this is so dangerous.
I would say yes, Louise. It would, in theory, work on anything where we're able to pinpoint it down to a particular set of genes or genome. Well, genes. In theory, yes. I appreciate today has been a real kind of introduction, because this is a complex area and it would need someone far more experienced in this to really give it justice. But I hope this has maybe introduced you to the subject and tickled your interest. Precise. There's a really good book that I started reading even more precise. The CRISPR Generation, the story of the world's first.
Okay. Now this is the big story here. This is the big story of the day. I was hoping to have more people on. ASDJAB. Chinese scientists reached milestone in revolutionary gene therapy for autism. Gene therapy for autism. This is being actively sought after. Right now. This is real. This is reality. This is the world that we live in, where they are trying to cure autism. Which means that, like, if they could cure autism, then they could give us a shot or whatever, and we would no longer be who we are. Because we would be cured of it. So we would be someone else from that cure. A genome editing system developed by Chinese scientists successfully modified a mutated gene linked to autism when tested on mice. It is the first effective treatment of mice with ASD-related mutations using base editing in the brain, according to the researchers. Now, the Chinese government, just like any other government, are going to consider autistic people a financial liability. A drain on the state's financial coffers. So if they could cure autism, then there wouldn't be billions of dollars or whatever it was for any particular country. That would no longer be an issue because these people would be cured and no longer be autistic. So they could be more productive members of society. And that's the way that this is going to be framed. And we need to keep this in mind. I like that picture, by the way. That's pretty cool. Chinese scientists have reached a significant milestone in creating the first injection that can undo the signs of autism through genetic-based editing within the brain. The treatment developed by researchers in Shanghai showed positive results when tested on mice. The team created a genome editing system which successfully modified the DNA of mice that had been given a mutation found in some patients with ASD. So this is direct genetic research to cure autism. This is what this is about. Giving an injection as a cure to autism. In a paper in their research published in the Journal of Nature Neuroscience on November 27th, that would be of 2023, so that's last November. The scientists said the potential treatment method could not just be used for patients with ASD, but other genetic neurodevelopmental disorders. And I've seen some references to CP today, to genetic research in CP. So I think it's probably related to the same story. but obviously directed towards those with CP. And CP people are